Welcome back to Daily Stand Up. So, system design is no different than code. It requires refactoring, it requires revisiting old problems, and that's what we're going to do today. So, I'm going to go to, I believe, our third 2025 system design video that we created this kind of basic system with queues, and we expanded our database horizontally to add multiple nodes to provide read replicas, and we introduce a couple background services. What I want to do is I want to expand on the queue portion of this design, and I want to make it a little bit more robust, but also a little bit more accurate to what's actually happening behind the scenes. So I'm going to do a couple things here, and to do this, I don't know if you all use Mac, but I don't know, like, I see this as an absolute necessity, as having in one of those, like, external trackpads that you can use the gestures with, just because you can scroll. Like, using a mouse to scroll, it's crazy. So that's what I'm going to be using for this. Again, this is in free form. So what I'm going to do is I'm going to go ahead and add a shape. I'm going to add a shape for an exchange. And what shape should we do? We always pick a different shape. Oh, we get objects. We can do a shirt, a bed. We're going to do a top hat. Why not? So we're going to make that our exchange. So the exchange is going to be, we're going to make it green. We're going to have a green top hat for the exchange. And I should say that our assumption last time, because this is going to make more sense for this video, is that our queue is going to be, or the message broker, excuse me, is RabbitMQ. So RabbitMQ implements the AMQ protocol, advanced message queuing protocol, which I have a hard time saying that, but AMQP. It implements that, and we use Mass Transit to connect to that. So that's what I did in my two-stroke engine project. It's a very widely used library. It's very, very good. So RabbitMQ is going to be our message broker. So that's going to be our queuing technology. So the way RabbitMQ works is we are going to connect not to the queues, but you actually are going through the exchange. And, oh, well, not like that, you're not. Hold on. I need to move these so we can add a little bit of space for ourselves. And let's move these lines like that. Now we can add our exchange here. Beautiful. And we will need multiple exchanges. Okay, 2 top hats. Now we can move this back and finish the lines, and I'm going to explain what I'm doing, so don't worry. Okay, so what I added was 2 top hats for the exchanges, and an exchange is basically the router for RabbitMQ's message broker. So when you publish a message, you're not publishing a message to a queue, you're publishing a message to an exchange that then the message gets routed to the appropriate queue that you have either bound to the exchange, or it's going to be routed based on routing keys or headers, a property. There's a number of different ways you can set up an exchange. You can have a fan out exchange. I'm going to write this down. This is you can have different exchange types. So an exchange, you can have a fan out exchange. You can have a topic exchange. You can have a direct exchange. And you can have a headers exchange, if I can spell exchange. And you can have a headers exchange. Those are the 4 main types within RabbitMQ that you can have, and they all serve different purposes. And if you're interested, we have videos covering headers exchanges, fan out exchanges, RabbitMQ, routing. We have all that on the channel. So go check it out in the System Design Series playlist, but we have it covered very in depth. I have very, very, very in-depth tutorials showing you performance, showing you different routing types, how fan out exchanges exactly work, diagrams, we have all that stuff. So if you're curious, it's all on my channel, so go check it out. But I'm going to assume that you've seen that, and now we can continue on this. So those are the exchange types. So for these, I'm just going to say that these, we'll leave these as a fan out exchange, just because I like fan out exchanges, and binding it to, it's not going to add really any overhead to just have it one queue, connected, bound to that exchange, rather than just have it a direct exchange to a single queue. Not going to see any latency from that, so I'm going to leave it as fan out exchanges for these two. And so technically what we are doing is we're publishing data to our exchange that then gets routed to a queue that then is consumed off of the .NET by the .NET background service. So that is the more technical, technically correct way of how this is working behind the scenes, because you can introduce a queue and you can have the connection in your system go directly from the system to the queue, but technically this is a more accurate representation of what's happening. And if you do this style, you can begin to add in multiple queues and still have the design make sense. And what I mean by that is this. So if I'm going to delete mass transit here. If we have, let's say we want to add another queue. I don't know. We have to scale it down a little bit. We added another queue and we want to just, I don't know, get a copy of the data. All we have to do in our system design is do this. And we're done. And it makes perfect sense. It's very accurate because this is what a fan out exchange is designed to do. It'll send data or route the message to all the queues bound to it. No exception. It just routes it. So this here is very technically correct, but it also allows us to expand on it. And so you can see if we didn't have the exchange and I had the connection directly from the .NET API to the queue itself, to add in another queue there, it would appear like our .NET API is publishing to two different queues, or trying to send messages to two different queues, which is confusing because if you take that, then you look at your RabbitMQ configuration, you'll be confused because you'll think you'll be looking for two different exchanges, which you're not. So this is a better way to do that, in my opinion, because it already gets you thinking for the future and thinking about, okay, how are we going to expand this, and are we set up to do that? So this is when you introduce the conversation about queues in your system design, if you are making the assumption that you're using RabbitMQ, just go ahead and add your exchanges so that way you can show the message routing. And then I think it'll open up the conversation for other factors that you can talk about, including the different exchange types and why you may need them. This gets down to the fact that, again, it's so important to consider like a niche technology like RabbitMQ and specialize, because if the more you specialize, the more you're going to be able to add things into the conversation that other people may not be able to. And especially if in an interview, if you're able to talk about this, I think it's only going to help your cause. And so a couple other factors that you want to talk about when you're talking about queues are the performance of the queues. So a queue out of the box with RabbitMQ is very, very fast. It's like scary fast how it's crazy. So, and again, we've done very in-depth benchmarking on this channel. You can go check out. But I am going to say we're going to do we're going to have some considerations for the queue. So a couple things that you may want to introduce into your conversation is the prefetch count. So the prefetch count is basically whenever you establish a connection to your consumer to your queue, you essentially create a connection. So your connection to RabbitMQ is on a TCP protocol, and basically a connection inside RabbitMQ is basically making a virtual, we'll call it a virtual connection. So how this works with prefetch count is basically when you establish that connection, it'll go through a buffer. And the buffer count is basically how many of those messages are going to be essentially prefetched. And that's a defined number based on your operating system. So that's at the OS level. You can configure that, and on Linux you can change the buffer count but you might break something. But you can change it. It's configurable. You can get really deep into OS level configuration. But prefetch count, you could leave it like, we'll call it, you could leave it at 10, 25, whatever, whatever it is. You could have your prefetch count, and you're going to notice an interesting consideration for speed. You're going to notice that as you bump prefetch count too high, you're going to take a performance hit. But if you keep it too low, you're also going to take a performance hit. So it's like you have to find a fine balance in there, and it's kind of exists on like this, like a graph. Like you get peak performance, slow peak performance, then it kind of tapers off. So you kind of got to be somewhere in the middle. So you don't want to go crazy with prefetch count for sure, but you also don't want to go too low. But you do want to have some prefetch count to take advantage of the buffer on the operating system level. So to keep the prefetch count, adjust that to something. You could keep it at, we'll say we're going to leave it at 20 for this video. We're going to leave the prefetch count to 20. Another consideration is you're going to want to make sure you have the delivery mode set to persistent. And I would say that you should always have the delivery mode set to persistent, because if you don't set that, then what happens is your message may get lost if the server goes down or whatever. So the persistence of the delivery message, meaning that the message is then saved to the disk rather than the memory of the server. So if the server goes down, you lose your message. If it's saved to the disk, the server comes back up, your message will still be there. So the delivery mode you're going to want to set to persistent, and I believe it's a flag. I think it's 1 for persistence. I don't think it's 0. I think it's 1. So then the next thing we want to talk about is queue durability. And queue durability you want to set to durable. Queue durability means that if your RabbitMQ server goes down, if the queue durability is not set to durable and it's set to transient, your queue is going to be deleted. But if your queue is set to durable, then your queue is still going to be there. So you really need to make sure both of these are set, because if the queue durability is set to durable but your delivery mode on the individual message is not set to persistent, then you'll maintain your queue but you'll lose all your data. So just make sure that when you're talking about this, make sure you talk about these considerations, because it's very important for data. Because you can add a queue and you can fix the throughput problem, you can fix the latency problem, but if you've introduced a breaking point in your system where you could potentially lose data because you don't set these things, that's not going to be good. So that's one consideration. I'm trying to think of another consideration that you want to make. You probably want to take advantage of. You probably want to introduce your retry policy conversation into this. Again, retry policy basically. So in your RabbitMQ, you have for the AMQ protocol, you have what's called a message frame, and on this message frame, you have the properties, you have the headers, and then you actually have the basically the message data itself. The retry policy basically takes advantage of the acknowledgement. We'll call it a header. I don't think it's actually a header, but just to visualize it, it takes advantage of basically acknowledgements. So when you consume a message off of RabbitMQ, it's going to pull that message off the queue, right? It's basically a destructive action. It takes the message off the queue and dequeues it. But if your server or your web app fails to process that correctly, let's say it goes down, you have an outage or something, and you fail to send that acknowledgement back, the receipt back to RabbitMQ, that message will actually be requeued. And it's very, very powerful bit of technology happening behind the scenes that the message broker utilizes. And so your retry policy that you can set within Mass Transit basically allows you to do that. So if it fails, you can retry again. So it'll consume it again until, however many times you set, until it sends that acknowledgement back to RabbitMQ. You can get way more into detail with that, but that's basically just an overview. But you should probably introduce since you've already brought in the fact about, all these other considerations, another consideration would be your retry policy. I'm trying to think what else would be a consideration. I mean, you can talk about highly available queues. Whoops, HAQs. So highly available. That'll start bringing in the conversation of actually creating a RabbitMQ cluster, which you can do, but it's not going to be an easy thing to discuss. I don't think in the context of a system design interview, but it's one consideration that you can bring up for sure. So we talked about that. So those are just some considerations. There's many more, but this should get you a really really good starting point, I think, for uh, your system design conversation. And again, I think it's very important that you add the exchanges, and probably don't make them top hats in an interview unless they have a sense of humor. But make it whatever shape you want. I have no idea what shape you should actually make it, but we're not fancy on this channel, right? We're using freeform and we're adding shapes and lines. That's really what system design is, right? So make it whatever you want. But yeah, so those are just some considerations. So hopefully it's helpful. There's a lot. You can go super in depth in queuing technologies, and there's other message brokers out there. Yeah, so there's a lot you can go into this, but thank you all for watching, and I'll see you in the next one.